Morning class. Today we're going to move on down the electromagnetic spectrum, which means we're going to be working our way from left to right. And we're going to be studying infrared rays, which follows radio waves and comes before visible light on the spectrum. So one way to remember kind of where it's at on the spectrum is because infra means below. And so infrared means below red. Well, you might be asking yourself, well, what does that really mean as far as what does it have to do with where it goes on the scale or the spectrum? As you've learned previously, just a little bit of information, we know that visible light, which often we see as white light, is actually a combination of all colors. So the Roy G. Biv is kind of what you're seeing when you see white light. And we can tell that it contains all colors of light because when visible light is refracted or bent, when it's going from one medium to the next, we see a rainbow. And so if you think about it, a rainbow starts with red. That is because red does not bend as much as the violet. And therefore, when we are thinking about this visible light is actually kind of split down in red, orange, yellow, green, blue, indigo, violet right here. So when we talk about infrared, that means right below the red of the visible light part of the spectrum. All right. Because we're moving from left to right, you should know that the wavelengths are getting shorter. So infrared has shorter wavelengths than radio waves, and their frequency and their energy is increasing. Now, infrared is a type of electromagnetic energy that we feel as warmth. And really everything that exists, anything that's made of matter, gives off infrared energy. So examples would be heat lamps and electric stove burners. We see those giving off usually red light, and so that's very visible to us that would be warmth coming off. We feel it and we see it. But we also, like people give off, or even the pencil that's in your hand, everything that exists is going to be giving off some form of infrared radiation. So thermograms. Thermograms are kind of interesting. These are pictures that show regions of different temperatures in the body or on different objects. And I have a couple here. Notice that when we look at these, the warmer areas of the body will be red and the cooler areas will be blue. So if you look at the picture on the left with the elephant, you'll notice that his extremities, his ears, and near the bottom of his feet are more blue and greenish color, and that is because there's less blood flow out there, there's less friction to moving parts like the heart and the digestive tract and the lungs and all of that. And so they're actually putting out less infrared electromagnetic radiation. If you look at the bulbs, you'll notice that the bulb on the right has a lot more red to it, and that is an incandescent bulb, which I also have in the two side lamps within my room. And then the fluorescent bulb on the left side of this picture is similar to what I have in the bulbs on my ceiling. And so you can tell that fluorescent bulbs do not give off as much infrared radiation. Lastly, if you look at the girl's ponytail, it is blue, showing that she is not giving off a lot of electromagnetic radiation in that part of her body, for the same reason that the elephant is also. Moving on to the right on the spectrum, we come to visible light, which we have talked about is kind of broken down from red, orange, yellow, green, blue, and then violet. So again, in your notes under important information, you need to have that these waves have a smaller wavelength compared to radio waves and infrared waves. And they also have higher frequency and more energy being transferred. So since red is on the far left of the visible light part of the spectrum, it has the longer wavelengths, and the violet would have the shorter wavelengths. And another important fact is that the red bends less when refracted, and the violet bends most when refracted. So as far as real life application, we've got, rainbows form because that light is coming. I mean, there is visible light coming from the sun, obviously, because you can see the sun, so that would be visible light. When that light shines through our atmosphere, it's going through mainly gases, and then once it gets into an area where there might be a lot of water vapor in the air, and it will bend and refract through that water, and therefore it causes a rainbow. We also have seen this with prisms before, or maybe you have seen it with some kind of stained glass where the light comes through and bends through, maybe, I don't mean stained glass, but like a little thing hanging in the window that is refracting the light, so we see rainbows on our walls and stuff like that. Moving on, this is just showing you again that the visible light is actually broken into the colors that make up that white light we see. So it reminds you of the order. And infrared is before the red part of the visible light spectrum. And as we're getting ready to move on to ultraviolet, it's important to note that ultra means above. So that means above or after the violet part of the visible light spectrum. So here are some prisms, and these are just kind of fun to look at. I like this one on the left a lot just because it looks cool, but it's also showing you the red. You can see the longer wavelength. You can also see it bending more than the purple, or I should say violet. This one I like also just because they're shining different filtered lights through here. So it's showing you one color at a time, and it's showing you how they would bend differently depending on what part of the visible light spectrum is being shined through. Shine through, one of those. All right, so moving back into ultraviolet rays. As we just said, ultra means above violet, so that means it's going to follow the visible light. If you haven't picked up on this, you probably are going to be asked to list the electromagnetic spectrum in order. So knowing where infrared and ultraviolet fall in relation to visible light will hopefully help you remember the order. Another important piece is that shorter wavelengths than visible light, infrared, and radio, we are moving from left to right, so it's going to keep getting shorter and shorter and shorter. However, there's going to be higher frequency and more energy being transferred as we move from left to right. So ultraviolet has more energy, which means it can penetrate through more dense material than visible light or infrared or radio waves. All right. So ultraviolet is kind of my frenemy, and I'm sure many of you have been touched, someone that you know has been touched with skin cancer, as have I. And so I like to talk about the positives of UV, but also just kind of tie this into real life information. So UV light can be helpful, and it can be helpful because it's very, it can help clean products. An example is in my classroom, we have the goggle cabinet. It is no longer working. However, there is a UV light in it. And what I used to be able to do is have the kids do a lab. And at the end of class, they would put their goggles in. I would lock the door and I would shut the door and lock it. I would turn on the lamp for 2 minutes. And that UV light would clean all of those germs and bacteria that we don't want to be sharing between people. And the next class would come in and they'd be clean. Now, there would be fingerprints and stuff on the goggles. However, the germs and the bacteria would be gone. Now, this also can be done in hospitals to clean equipment between surgeries or different checkups or whatever. and making sure that we don't transfer those illnesses and diseases between people. All right, jaundice is something that you may or may not be familiar. Many babies are born with jaundice, and that just means that they are lacking the amount of bilirubin in their body, which I'm pretty sure is made by, I want to say maybe the pancreas or the gallbladder. I need to better research that. But basically, vitamin D helps provide our body with what we need in order to restore that bilirubin in our body. So oftentimes babies with jaundice, sometimes if it's a mild case of it, they'll just say, hey, you know, when your baby's sleeping, make sure they're sleeping in a crib near the window, or, you know, when you're holding them, make sure that you're just sitting by a window and let them get that vitamin D. Or they might say, okay, this is a little bit more stronger case of jaundice, so we're going to place your baby under a UV light for so many hours a day while he's in the hospital. So those are some good ways that UV light can help us. Another way is that it causes our skin cells to produce vitamin D. So vitamin D is necessary for our health and the strength of our bones. And so we are able to produce more of that if we are getting enough UV light. So obviously there are the negative side effects of too much UV. One of them is that you can get burnt easily, skin cancer, and even damaging your eyes. People forget like how important the eyes are to us and how we can protect them. So skin, I'm going to go into that a little bit further on the next slide. So you'll see that there are actually 3 types of UV light that come from the sun, A, B, and C. Isn't that easy? The ozone layer, when the ozone layer is, you know, doing its job, it does that. It does block the UVC light from getting through the atmosphere, which is kind of nice. We don't have to worry much about blocking that light. There are some areas around the world where I think that they do worry about that a little bit more because there is a little bit of breakdown of the ozone layer in some parts of the atmosphere. Now, when UVA and UVB light are 2 other types of UV light that come from the sun, and we need to make sure that when we're out in the sun, we protect ourselves from those by wearing sunscreen. So sunscreen, there's cheaper kinds that don't really protect against all UVB light, and so we want to talk about, you know, those. And sunglasses as well, not all of them protect. So what you want to do is find sunglasses and sunscreen that says protects against the broad spectrum, or 100% UVA and UVB protectant. And the reason why I say that is because UVA can, I think it's the UVA, it could be the B, I'm kind of blank. I think it is totally UVA that can go deep within your skin. And so what happens is it gets down into where skin cells are being kind of manufactured or produced within your body, and therefore they are kind of deformed. UVB is where the top layers of your skin are being damaged from the sun. So some cheaper sunglasses or protectants are only protecting our skin in from one form instead of both. So moving on to x-rays, some of you are very familiar with x-rays. Again, these would have shorter wavelengths, higher frequency, higher energy from the types of waves to the left on the spectrum. Because these have more energy, they can penetrate most matter. So something that they can't penetrate all the way through is bone. So what happens is when you look at an x-ray, you would notice that the bone, and I'll flip over to this real quick, the bone or a solid, a very dense solid, would reflect or block the light rather than letting it go through. So if you see here, there's some gray areas. So this gray area of the hand is skin and ligaments and cartilage and stuff like that. And so it can, the light can go through it. However, this bone is a little bit more dense here, and so the light cannot. So it is blocked or reflected here, and therefore it appears white. If you